Hello, good afternoon. Welcome to our webinar, Building Serverless SaaS on AWS. Today's agenda, we will introduce you to myself and Zero&One, and then we will discuss the benefits of SaaS and what are the best practices in building a software as a service platform. And then we will jump to the core of this webinar, why serverless is a natural fit and how we can overcome several challenges. And at the end, we will have a Q&A session. I'm Ali Al-Kuntar, founder and CEO of Zero&One, 9 times AWS certified and AWS authorized instructor champion. Zero&One is an AWS advanced consulting partner, one of the top partners in the MENA region, specialized in DevOps and building native platforms on AWS, and recognized as a well-architected partner. So according to Gartner, they estimate the market size of the SaaS marketplace to be around 100 billion in 2020 while growing at the rate of 21%. According to IDC, 72% of enterprise will prioritize SaaS when selecting a new application solution, while only 13% prefer traditional applications over SaaS. So what are the major SaaS benefits? Service companies are gaining some additional benefits from adopting SaaS models, which are not accessible to traditional ISVs. By unlocking new customer segments through lowering the customer adoption costs and operational costs per customer. The second benefit, reducing TCO, which reduce the upfront infrastructure cost and eliminate customer support costs. Integrating new cloud services by leveraging off-the-shelf components available in the public cloud, reducing time to develop new functionalities. And fourth advantage, leveraging aggregated data, where you can drive new customer insights from usage data, develop new data-driven solutions, and even monetize this data. So in contrast to any traditional licensing model, subscription model allow customers to use the software without committing to long licensing periods and thus lowering their barrier to buy. And at the same time, from an ISP perspective, this model smoothens the revenue curve through monthly recurring revenue, resulting in improved financial predictability. So what are the best practices that we have seen through different ISVs? Successful ISVs has built their SaaS business around 6 core capabilities: multi-tenancy, microservices and serverless, automation, single code base, data as a platform, velocity of innovation. So the key for building these 6 capabilities effectively is to use the capabilities provided by public cloud platform like AWS, and I will walk you through each of these capabilities in some details in the coming slides. The first benefit is multi-tenancy. So successful SaaS vendors provide standardized service to all customers through multi-tenancy. This means that they provide a single shared application and data layer to all customers without customer-specific instances. In contrast, the traditional single tenancy model results in high costs due to maintenance overhead of keeping application instances in sync across the installation base. Your different instances will also easily drift apart from each other in terms of code and configuration. Some organizations opt for limited multi-tenancy where all the customers share a common application layer, but the data layer is kept in separate customer-specific instances. This can be a useful model for organizations whose customers are following strict data compliance regulations and must keep their data in a specific geographic location. The full multi-tenancy model provides the most value by allowing teams to focus on developing and maintaining a single version, leading to lower TCO and easier maintainability. In a full multi-tenancy, customer-specific variations can be built into the software as components that can be turned on or off based on the need. We will jump into more details about multi-tenancy when we talk about the specifics of building serverless SaaS. The second best practice is focusing on functionality rather than integration by using microservices and serverless. With microservice architecture and serverless, companies focus on the functionality rather than the integration. We tell our customers that whenever they start developing something new to their SaaS solution, they should always think if it can be implemented using serverless like AWS Lambda. So if serverless is not an option, then build the new functionality as a microservice. So serverless services allow you to build your functionality as event-driven components that are executed on demand, triggered by specific events like database change, log activity, or etc. So serverless functions speed up development and deployment time and can significantly reduce cost as you only pay for requests, not for the idle time. Well, the microservice architecture has been around for a while, but it is interesting that so many ISVs are still stuck in the world of traditional monolith. Microservices are built to separate functionality as independent components, where the functionality is offered through APIs and that can be developed and maintained without having to worry about dependency issues. Data as a platform. Shared platform allows SaaS vendors to leverage insights from data aggregated across applications. In fact, a shared data layer is fast becoming the number one capability many ISVs and SaaS providers are after, and which sets apart the successful providers from the rest. There are still many organizations that are not able to leverage data across their customer instances in an effective way. So, public cloud offer unparalleled capabilities to build a consolidated data asset from your service. So even if you are keeping your customer database in separate locations, you can still benefit from having a shared data lake for insights and analytics. However, you might have to anonymize in case of strict data policies. So shared data layer for applications is important not only for sharing data and getting platform-wide analytics, but also for compliance and auditability. Using cloud platform services like AWS Lake Formation, it's possible to build shared data layer with detailed access controls and audit trails. Having a single code base can sound like an obvious thing, but maintaining a strict single code base policy requires dedication. SaaS vendors with multiple different versions of the code end up spending more on change implementation, deployment, and maintenance. So instead of building customer specific functionality to different code base or versions, you should have a single code base and build customer specific functionality into common build through config options. This is in line with what we have discussed before in multi-tenancy. Successful SaaS vendors minimize any manual steps and build end-to-end automation across development, testing, deployment, and operations. Automation capabilities and DevOps tool change can drastically improve delivery quality and speed to market. For instance, on the infrastructure side, companies should use infrastructure as a code like AWS CloudFormation to increase automation and consistency of environments. So companies should utilize the full DevOps tool chain that automate the workflow from coding to deployment. Automating the whole workflow is very important as any gaps in the automation will effectively become a bottleneck and kill the benefits that you were hoping to achieve. So, as your development teams will have more responsibility in the SaaS model, it is important to perform automated security and compliance tests. So, start with automated reporting and compliance checks inserted into your CI/CD pipeline, complemented with cloud environment best practices versus anti-patterns check. So, the last benefit we're discussing today is the last common capability for successful SaaS vendors based on our experience in enabling velocity of innovation through public cloud. So having the possibility to shoot up a development environment in minutes or building your prototype as a serverless functions utilizing cloud native pre-built components can have a massive impact on the way you introduce new value added services to your customers. So why serverless and SaaS? So one of the trends we have been seeing over the few years is this strong move by SaaS organizations, especially startups and even established organizations, who are saying we are very interested in the value proposition of serverless and what it does for SaaS environment, and they are very compelled to say we would really want to take advantage of all the goodness of a SaaS architecture delivered in a serverless model. So we see all kinds of efficiencies there. So what kind of end-to-end list of things that you ought to be thinking about as you build a serverless SaaS architecture for yourself? It won't be comprehensive list, but it is a lot of the sort of nuances and things that we see are really important decisions that you would have to make if you were sitting down building your own serverless SaaS solution from the ground up. So in this section of the webinar, you will find bits and pieces that you can take away and map to any serverless SaaS solution you might be building. One of the great innovations of public cloud computing in recent years has been the advent of serverless computing. Serverless computing allows you to focus on writing and deploying software components without the need for focusing on the underlying infrastructure. The software components, often called functions, are executed based on a defined set of events, and compute resources are consumed based on the usage during execution. AWS Lambda was the first publicly available serverless computing offering. Lambda supports natively Java, Go, PowerShell, Node.js, C Sharp, Python, and Ruby runtimes. It also provides AWS Lambda layers, which we will discuss further down the line, which allow you to use any additional programming languages to author your functions. So, benefits of serverless. So, serverless SaaS architecture offer a number of advantages where you focus on value adding activities like writing code instead of designing and managing infrastructure, speed up development time and simplify development of a new functionality by breaking it down into small pieces of functionality. Then optimize infrastructure cost by consuming only the computing resources required to run the code with 100 millisecond billing. You don't pay for the idle time. Get the benefits of auto-scaling of infrastructure resources. So there are also some drawbacks of going serverless, like testing, especially integration testing. It becomes more difficult as the units of integration becomes smaller. So no more over provisioning. The blue line is the actual activity of the tenants, which is changing and moving all the time. So which tenants are in my system and how and when they are consuming the resources of my system. So when I'm building a SaaS platform for my enterprise or startup, I will be asked to build an architecture that can follow the blue line, so we do not spend much on the resources. So in the dream world, I would try to make the gap as small as possible all the time. This is the dream view of a SaaS architect. So here is where serverless shine. Serverless and the managed nature of it takes the overscaling for you and lets you just write code, deploy code, and let it figure out how to scale it. It makes your microservices and decomposition much simpler. It makes it easier to avoid situation where you are worried which policies you need to scale, and this is all become the job of Lambda. So on the right hand, I show a generic serverless architecture. So when designing the architecture, one of the first things you need to do is to define the granularity of your microservices and functions. By making your functions too large, including lots of functionality into the same function, you lose some of the flexibility and speed of development. It also makes it harder to debug your functions and makes your software less fault tolerance. So serverless technology will allow you to build functionality driven events without having to care about the underlying resources, and it will speed up the development and deployment time, and it can significantly reduce cost as you only pay for the requests and not the idle time. With serverless, it should always be your first resort when thinking of adding new functionality to an application. So adding tenant to the context. When building SaaS applications, you need to be able to do tenant isolation, tenant management, tenant metering, and monitoring. You need to be able to identify and authenticate tenants and offer different tenants different sets of functionality based on their subscription tier. You also should make sure the performance is fairly distributed among tenants and monitor the usage to identify upsell opportunities and gain valuable insights about usage patterns. So on AWS, you can implement all this with the help of Cognito, which we will be discussing into more details how we can overcome the multi-tenancy challenge when building our SaaS architecture on AWS. Let us now look at the first piece of a SaaS architecture landscape, the onboarding. Usually, when we talk to customers, the typical answer is that's not something we need to think all about. We are more interested in microservices and storage. Eventually, onboarding is one of the most important pieces of building a SaaS solution. Getting onboarding right, how tenants get introduced into your environment, how you create a footprint for a SaaS tenant, is essential to the rest of the architecture of your solution. How you resolve a user to a tenant, how that tenant has a billing lifecycle. So now what provisioning you might have to do in configuring to set that all up. I will share in the coming slides how to set up the flow through all this in a way that make your developers more productive and making your isolation story even better. So we want this process to be really robust. You don't want tenants trying to onboard onto your systems to have somewhat flaky process. You can't have it fail every other time and you just retry. The next thing we're gonna look at is authentication. On the surface, you would say, well, authentication. I know that I have to write a code that connects to an identity provider and auth all users and get them into the system. But right here in a SaaS environment, we are not just authing you as a user to get you into the system. We are not going to talk about how to do that. What we have to do is when I auth you as a user, I have to know which tenant you are connected to, because the context we need is you as a user for a tenant. So when we auth you, we are going to look how we auth you and how we get an identity profile that flows all the additional SaaS context through our app. Now let's look at the actual way to build multi-tenant services. Here is where everybody thinks, well, this is where the nuts and bolts of real good architecture and real good SaaS design gonna come in. No, not really. The truth, in fact, to write a really good multi-tenant solution, you have to build a really good isolation model and a good identity model. So our goal is to build a multi-tenant application services that do not look at all different than building a single tenant service. We're gonna look instead at how we surround these services with frameworks, tools, libraries, and mechanisms that will take all the multi-tenant context and hide it away from these services. So then there is the storage partitioning. This is often uh, a lot of people, when looking to SaaS solution, they think that they will essentially take an environment, then make a database for each single tenant, and everything else stays the same, and that will be their multi-tenant environment. We are not going to dig deep into this webinar as we have the limited uh, timing. So the last piece is one of the most that gets overlooked, which is this notion of tenant isolation. So if you think about selling a SaaS product and you think about somebody coming to you and buying your product, who may be in a space where they are very worried about their data and how their environment and their resources are protected. You must have a scheme that you can share with your customers to explain how you have done it and how you ensure that their data and resources cannot somehow be accessed by another tenant. So imagine having a SaaS business and having some tenant come come back to you and say, hey, I'm seeing somebody's else data. So what kind of ripple effect is that gonna have through your business? That's gonna be huge. So we have to look at tenant isolation, not just from the perspective of authentication. Yes, we want to auth people. We want to be sure we have good security where we get from the front door. We want to look at how we can build layers of security in here, a multi-tenant security, and we want to look at ways that we can apply policies and rules to prohibit cross-tenant access. So if you think that identity and isolation are just some tangential concept, no, they are gonna flow through this whole discussion because they are table stakes for SaaS solution. So finally, you should consider metrics management and billing to complete this basic landscape. We're going to touch base lightly on those towards the end. If you look as a serverless SaaS architecture, we are moving towards a model where our microservices are using Lambda functions. So generally, your web app will be hosted in S3 bucket using React or Angular and running in the browser space. Then the APIs of this application will come through the API gateway as an entry point to our application service, which will route all the incoming requests toward the underlying microservices. So this diagram doesn't show all the moving parts of a serverless SaaS architecture. We have all these shared services we have to build. More of horizontal service supporting the fundamental block and tackling building a robust SaaS architecture. So think of your SaaS architecture as the union of these two things. Let us start from the outside in. We must start with onboarding and identity. So those are the foundational elements as discussed earlier of building your SaaS architecture. The mechanism we will build will flow through all the layers of our architecture. If you jumped in to write your serverless architecture and came back to implement the multi-tenancy later, you will have to rewrite the code again. I've seen customers who will say, we have one important customer, we will finish this first and add tenancy later. Eventually, they have to write the code again. So let's walk you through the mechanism. We've got a registration service that comes in represented in one or more some Lambda function that are responsible for the request in. The request goes out to a user management service that says, hey, I'm gonna orchestrate the creation of the user and their identity in the system. I will go out to an identity provider and provision the actual identity of the user coming in and the tenant that is getting created here. In this particular case, we are showing Cognito here. We are going to use a concept called user pools, which essentially let you set up a set of policies in a grouping construct within which group of users will live. You can create user pool at the tenant level, which is an awesome thing where you can configure all the tenant level things at the user pool level like password policy, password complexity, MFA, and other good things that you might need to set up tenant by tenant base. So one important step is the custom claims. Custom claims are those OpenID Connect concept that lets you essentially have a set of properties and attributes that you can shove in into the actual token that will come out of this process. There where you can put the tenant identity, the role, the tier, and all those other things that will be important to you downstream. So you got that provision to there. You are also going to provision the isolation footprint here, the policies and the roles and the other things that we will need to enforce tenant isolation. Once we are done with that, we can come back and actually provision the tenant. You may be wondering why we are provisioning the tenant. We just did that with the user. No, the tenant is separate from the user. In fact, after we are done from the initial provisioning, we can have any user connected to that tenant. That tenant is still one global construct, which is what is the tenant identity, what status is that tenant are active or inactive, what tier are they are part of, that is independent of what the user might be associated with. And then finally, this provisioning section, which we might need to provision some resources as part of the onboarding. You might need to provision more Lambda functions, depends on the model, your infrastructure. So we still need this to be automated. Now we got our tenant provisioned and our user registered. The next thing would probably be the most obvious and straightforward part. You get a login into the system. You will certainly gonna go out through some authentication manager service because we're gonna actually have to resolve which user pool in which is one of the bad parts of using user pool. So actually it is something that has to resolve the user to the user pool to be able to authenticate it. And then you can get going to go out to Cognito and authenticate that user, and back from the process will come the token. and that token will actually be enriched. So it's just a JSON web token. Think of it as a JSON object that has essential properties and values, where some of which are standard to OpenID Connect, but also in there you will see in that web token are my tenant ID, my role, and my other attributes that you have used to enrich this token to give me tenant context. So that token is going to be key to how you partition data, how you isolate tenants, and how you do everything else downstream. Now let us stop for a second at the API gateway. Once we have that token out of that process, we will flow that into the API gateway, and now we are sort of headed into the actual capabilities of our services. So tenant context will be flowing into all the downstream services. There are some multi-tenant things we need to think about at the actual API gateway level. So as we come in here and our tenants come into the API gateway, and this token we have now that comes into this API gateway is here, this is the first opportunity for us to stop and ask, what can we do at this level to implement our first layer of security? Because this is the entry point into all the services of our system. So what can I do here to enrich the security model of my system? And actually, we have an opportunity because we have this token. We know who you are as a tenant and what role you are in, and I know what tier you are in. We have that kind of data. So we can actually go use Lambda Authorizer. This authorizer is essentially a Lambda function that will do whatever you want it to do. You will write it, and in this case we're gonna say this Lambda function is going to crack open that token that comes in and is gonna look at your attributes as a user, and it's going to say, hey, you are tenant 1, you are in this particular role, you have this particular tier. I'm going to configure a set of policies for you that will say these are the routes that are valid for you. So I will disable certain routes and enable certain routes. So now we've already got some extra level of comfort from a security perspective here, because you can't even get to some of the services beyond the API gateway if you don't pass this authorizer. So this is a really good way at the outer edge to put these barriers in place to make it more rich security model. So there is also bits we can do here that are that more multi-tenant orient. So which is as traffic comes in through the API gateway, we can often have the need to say, hey, certain tenants may be saturating the calls to the microservices. They may be impacting, creating noisy neighbor kind of situations. And we have these tenants, our basic tier, who are paying us $99.99 a month. And I have this advanced premium tier who are paying me $1,000 a month. We would certainly like them to have different experiences as they come through this API gateway. At the minimum, I don't want the basic tier affecting the premium. So here we have the option to use what is called the usage plans. They let us configure the policies and when throttling will be applied. Here we can have two separate API keys, one for the basic and one for the advanced. And hey, you are basic tier and your usage plan will be throttled. Super powerful option and a great way to differentiate the experiences of consumers of your environment. So finally, we are beyond the API gateway. What do I have to think about as I now make the move into the actual microservices and the Lambda functions that are running my actual application. If you remember earlier, I said we have to think about provisioning potentially as part of that onboarding process. And it turns out that both provisioning and isolation are the first things we want to think about what's going on to be in my microservice layer, because ultimately people gonna buy your product and different tenants of your systems are going to have different expectations of isolation. Some tenants will actually say, I'm good with whatever isolation, I trust that you will get it right, and I just want features and functions, and I just actually that thing to work, and I want to get good value for my money. Other tenants are going to be like, I'm highly regulated environment. I will not run your system unless you give me this very isolated experience. And then some people who are kind of in between. I want this part of my experience to be isolated, but the rest could be shared by its by by everybody. So this directly influence how we choose to provision the microservices of our serverless SaaS environment. So if you look at this model here on the left hand side, you will see that basically we have implemented what we call a silo method. Silo basically says all of the resources or some of the resources that you are working with here are siloed for this tenant. Only this tenant will be running those resources and no other tenant will be sharing them. In this silo model, we can do really powerful things with IAM. What we can do here with each one of these Lambda functions deployed for each one of these tenants is when we deploy it and configure it and send it out to the world, we can attach an IAM execution role. So we attach an execution role to that function. Now that we have this role attached to that function, there is no changing in it. It defines the scope of what that function can do, what it can access, what resources it can touch, and it is core to your isolation strategy. Now, the opposite side of this, and the one we often target because we want the efficiencies of it, is what we call the pool model. The pool model is one where the resources are shared by all tenants. So now when we deploy one of these Lambda functions and we push it out into the universe, we can't deploy it with an execution role. That is an execution role of a tenant, and I can't change the execution role at runtime in any way. So once it is deployed with that role. So we have no choice here but to deploy with a much wider execution role that have much free reign access to all the resources that are needed by these microservices for all tenants. Now, my isolation story is not so awesome over here. Let us stop before we go forward and talk a little more about this and think about that you probably when you go and build your system you will have some notion of, okay, there are some set of tenants who want everything in the silo model, and we're gonna have to support that, and we'll deploy an entirely separate footprint for them, their own Lambda functions, everything. So there are some of who are saying we are all good with the pool model. We are all in, will be there, but the reality is that you can choose a set of services which are premium services of your environment where isolation is the most important piece. So make those isolated per tenant basis or per tier basis and run the rest of them in shared models. So don't think of this as all or nothing. Look for something between. We still prefer the pool model. It's easier to manage and deploy and give more agility. So we will always push to the pool model if possible. So let's dig more into the isolation side of this. We have an execution role, and as I go to access S3 bucket or DynamoDB or some other resources, that execution role will be applied to those Lambda functions, and it will scope my access to the other bit I want to touch. So if I'm tenant 1 and I want to touch a bucket that belongs to tenant 2, it will not allow me to touch that bucket. The other piece of the silo story is this notion of reserved concurrency. So I want to emphasize the idea of reserved concurrency is very powerful mechanism in tiering construct. So what is reserved concurrency? It is that you can take for a function how many concurrent instances can be running at the same time, and we can add a cap on it. So you are not allowed to run more than X number concurrency. If I have different tiers in my system, then I want to make sure that my premium customers are never going to have an issue where there are noisy neighbors. If I have somebody in the basic tier who is hitting some functions so hard that they are running above the bound of the concurrency of this function, I do not want some premium user to say that the system is degraded or we are not having a great experience. So what we encourage you to think of how you can use this reserved concurrency and say, yes, here is the cap of the functions deployed in the basic tier, and we'll deploy a higher cap in the advanced tier, and whatever left in the big pool allocated will go to the premium tier. So let's go back to the pools. We talked about roles and execution roles and how great they are in the silo model. But what we do now in the pool model, where we have a more wide open security model, and we have multiple tenants now coming in, and we need to have somehow an isolation context. So we are going to have Lambda functions that are shared by all the tenants. It's true that any one of these functions at any time is even going to be running just single tenant, but don't confuse this with isolation. Even if I'm coming in as tenant 1 and I'm the only one executing this function, in the code of the function, somebody can write some code because it's still open to go touch some data from tenant 2 or 3 or so on. So you are not isolated because one tenant can execute it at a time. So then we have to come up with some way to do this. You have to have some sort of convention of compliance where somebody says, I'll come in, I will go out at runtime, I will resolve this to some token that is a token that will be the token that is the scope of the particular tenant at this particular time. And now I will use that token and come back. That token will flow through, and now I'll have code in here that says as I go to access resources, I'm going to use this token that was given to me. It will scope my access to resources and limit my ability to see just those resources that are available to me as a tenant. Now, nearly as elegant as the silo model, but still mostly something that can sort out, hide away the developers and just make it work. Now, where it gets more interesting as you say, oh, cool, we got all those microservices composed of multiple functions, but what does it mean to write a multi-tenant serverless microservice? So the goal is always to let our developers experience transparent as possible from the multi-tenant notion. So if someone is going to build a new microservice and all through their code they are thinking about, I've got to get the tenant ID, and because I have the tenant ID, I do this specific thing. Now with the tenant ID, I see tenant context through all the code. So that is not gonna be a manageable experience, neither productive. What we are trying to do here is take all those concepts that are related to multi-tenant and take them out of the view of developers. Push them out to the edges, use frameworks or libraries. Do not get super heavyweight and go for 6 months to build a logging framework for multi-tenant. Just move them to the edge. This is a simple example here. Logging metrics, for example, need tenant context. You need to get the tenant context and inject it into the log. We do not want the developer to worry about this. Same for partition data access. We just want the developers to go get data required without worrying about tenancy. So that's why we're introducing Lambda layers. It is a mechanism to implement those horizontal shared concepts to move this tenant awareness away from developers. So if you haven't seen that, it's a cool mechanism to just say we have all these modules, shared files that are used across all those functions. I don't want them to be deployed with every single function. So they introduced the notion of layers where you could put the shared construct there, reference it, and then all the functions that are needed could just be called in. It can get versions separately, deployed separately, and so if I make a change to the shared construct, all the different functions that reference it will be able to get that updated version. You can imagine that mechanism wasn't created for our nice SaaS problem, but it's also fit for that problem. So now what we can do is I've got a product service, we've got an order service. I don't want them to know anything about multi-tenancy. I'm gonna go create this layer. I'm gonna push it into this layer and has all the common sort of multi-tenant context. So here we're gonna take this logging manager and metrics manager we already talked about, and we are going to call the logging manager and say log some message. We will take the JWT token that come into me as a service. I don't care what is in it. As the product service, I'm going to say log a message. Here is the context. I don't know what is in it, and I'm gonna send it over to the logging manager. The logging manager is going to go to some token manager. The token manager will be signing and all good things that you have to deal with. Crack open the token, get your tenant ID, inject it into the logging call, and log with tenant context. Nothing really special about that, but really a big win for this as you look across all the amount of multi-tenant code that we have pulled out of these services. So what does this look like as we land in an actual code? Here is a little node example. In the left hand side, you will see the view in the IDE. You see the highlighted layers in Node.js where we have the log manager, partition manager, and token manager in there. You also notice the other services such as auth manager and course manager in this example. So all this code will be pushed and deployed into a layer in your environment. So the code snippet on the right hand side, you can see how we define and indicate references to those libraries that are deployed into layers. So it just looks like any other dependency. You would put it in any file, but however, you will notice the prefix of the file names have the particular convention slash opt/node.js. Layers require you to use this specific convention so it knows how to resolve where to find those things. So that it is not the folder name on your local machine, it's the folder as it gets deployed into Lambda. So if we go a little further with this and dig into the token manager, we will find that the token manager here is basically getting the tenant ID, which get an event passed, and it has all the headers. So we will put the authorization header out of it, and then in the authorization header we will actually poke it and parse it out the JWT token, and then we will unpack it using a signing key, and then we verify the body, tenant ID that actually gets my tenant ID back, and we pass that back. It is not too much of code, but we don't want this code to be in all the different functions of our solution. The last piece of this is the payoff. So we said we want the developer to have the best experience. When you look at this, you will see the log manager. It is calling the layer, passing event through, and it's done. There is no tenancy, and the word tenant nowhere appear in this function. If you look at the data access layer, get course will go get the right courses for the right tenant without any tenancy included. Now, the last piece we need to emphasize the service decomposition for SaaS environment. Think about the fact that now you are in a serverless SaaS model. How does this affect the scope and the boundaries and the size of the microservices that you build? If you think about it classically, if you go build for a traditional container or EC2 based model of scale, you're going to create a service, and that service is going to have a series of entry points into it. If one of those entry points happen to push the service it on, let's say put or delete and saturate the service in some way, and the other functions are barely moving the needle, my only option in my only unit of scale here is the whole service. So I spin up another container or another EC2 instance, and by the way, I have to write the policy that manages that scale. So it's my job now how and when it's scaled. So tenant coming in, out in different manner, and probably I have to change the policy regularly. So which is against the graph we discussed in the beginning. So now take the example, the same exact model, and say that what does it look if I'm in a Lambda serverless SaaS model where these same functions are there, but now each one in a separate function. The get, the put, the post, each of them correlate to a separate Lambda function. Well, now what is my unit of scale? Each function gonna scale independently. So if you were not using any of the functions but one, I won't be paying for anything but that one function that is running. And if that function really wants to push really hard for some period of time, I will let Lambda scale. So my unit of scale now is an individual function within that microservice. Now this will change your thought process when it comes to decomposition, whereas the top model you might have said, oh, I'm gonna break, delete, or put, or whatever is getting saturated out and make that a separate microservice so I don't end up with this noisy neighbor problem. While the model down below, if one of them gets saturated, I will just let Lambda scale. The big payoff, no policies. You are not writing policies or chasing scaling. Now at the end, let us summarize some of takeaways. So serverless enables SaaS agility, resilience, and innovation. Isolation strategies directly shape deployment footprint. Consider supporting multiple isolation models. Factor account limits in your isolation model. Hide details of multi-tenancy from service developers. Consider using layers as the home for shared multi-tenant concepts. Serverless allows us to better align tenant consumption and activities. At the end, I would like to thank you, and we still have some time for Q&A session.